We have with us Julian Egelstaff, and he's been working in the IT industry for over 17 years. He co-founded the Freeform Solutions, which is a not-for-profit organization that is whose mission it is to help others use technology effectively. And he's also the lead programmer for Formulize, which is an open source project which is designed to provide non-programmers and help them create databases on the web. Julian holds a Bachelor of Journalism and Philosophy and is a Zen certified engineer. So please join me in welcoming Julian.
Thank you. Thank you very much. Thank you for coming. Thank you to our friends in the cloud who are joining us too. This is being streamed into the cloud, which is so cool. Teaching coding to grade school kids. Who has kids here who are in grade school? A few, some. I hope some of you might be inspired to consider doing something similar with your schools. I have the benefit of working from home, so I can be flexible with my time more than some people. So it's not a problem for me to go into the school on Fridays and do this. Yeah, I encourage, my main point in doing this is to explain what I did, how it worked, what the kids liked and didn't like, and so on, and provide all the resources so if you want to give it a shot or pass it on or whatever, you can. My motivation comes from the complete loss of computer science curriculum in the primary grades. Computer class, showing my age, used to look like this. You booted up your computer. This is an emulator running on Windows 7, but you boot up the computer and immediately you're ready. And you can start programming. You don't have to launch an IDE. You don't have to configure the flux capacitor. You just start programming. This is Atari Basic. I had an Atari 800. In school, we had Commodore 64s. It took me 6 months to figure out you had to dimension strings before you could use them in Atari Basic, so that was very frustrating. But I remember doing this in grade 4. The teacher you'd have a room of Commodore 64s, and this is what you'd do. The semicolon at the end of the line there in Atari Basic means retain the position of the cursor. It's not a line ending indicator because this is basic with line numbers, so the line number means the line. So what is your name? Input your name. Now we're going to print the name, and then comes the punchline. Some of you may remember this depending on your age, but some of you I think are too young to have done this. Here we go. Run the program. What is your name? Ha ha! That's hilarious. Isn't that hilarious? When you're in grade 4, that's hilarious. And a whole room of kids doing that, that's exciting, and it's fun, and it's simple, and you have an integrated IDE into your environment, like as soon as you turn on the computer. It's phenomenal. Okay. You turn on the computer, no barrier to entry. And you learn that the computer is a tool that will follow your instructions. It's like this whole other world opened up to people. Now, 30 years later, computer class looks like Microsoft Office. My kids know more about Microsoft Publisher than I do. You turn on the computer, and after it boots up, and after you've logged in, because they've all got their logins with some special password that the school server recognizes and whatever, and then you find the right icon somewhere, and then the program loads up, and then you can use software. But they only teach them software. They don't teach them anything about actually interacting with the computer. So you learn that it's a confusing mess with more switches and buttons and things than you ever are going to need or understand or anything. Who here knows all the commands in Microsoft Word? It's just overwhelming. That's why they invented the ribbon bar at Microsoft, because there was too much stuff and they had to group it in a better way. We could debate the ribbon bar later, but anyway, yeah, like it's totally different. In 30 years, the focus of what they do in grade school computer class is totally changed. There's no resemblance. But I knew it could be different than what it is now, because that's the way it was when I was in school. And this is very important to me, because if you were paying attention to the introduction, you will have heard that I do not have a computer science degree or a computer engineering degree. I have a journalism and philosophy degree. I was only successful getting into this business because when I was in a computer company and was given scripting tasks, I knew basic programming. And I got better and better and better at doing that. And eventually, I founded an IT company. So I may be a bit of an outlier, but for me personally, I would not be doing what I'm doing now if we hadn't been doing computer class that way 30 years ago. And it really upsets me that kids these days are missing that opportunity, completely missing that opportunity. So how could it be different? What could I do about this? Well, let's look at the barriers that are in the way. There's the Ministry of Education. The curriculum is wrong. That's the most fundamental problem. People's idea of what a computer class is wrong and needs to change. Well, it's not wrong. It's important to teach people applications and understand how to use these tools for when they need to use them. But there's this whole other side of computing that has vanished, and it doesn't need to. Teachers. This is maybe a bit of a controversial statement, but I firmly believe that teaching attracts people who don't like computers. We've done work at Freeform. We do work with lots of not-for-profits and public sector groups, and I can tell you our spectrum of evidence is that the closer people are to the education system, the more computer illiterate they are. That would be the anecdotal evidence from our side. And you don't need to use a computer to be a teacher. Day to day, you're teaching, which is a wonderful thing. I have the utmost respect for teachers. I've spent more time in classrooms than many parents because, my flexibility. But they don't like computers, and they don't understand computers, and that's a problem, I think. It's getting better. So obviously, it gets better with time as more people who grew up with computers become teachers. And the tools are not there. You don't turn on the computer and get the ready prompt. You got programming environments that are hard to install and have to be maintained in certain ways. And the school computers are badly maintained as it is. And they're locked up, so you can't install your favorite IDE on them or anything like that. So what can we do anything about? Career in politics was beyond what I wanted to get into. Can't retrain all the teachers, I don't think, really. But I thought that even with the computers in the state they are in the school, the level of the tools could be addressed. Because I'm a web developer, that's the kind of programming I do, and you don't need a lot to make a web page. You really don't. The barrier to entry for web pages is actually shockingly small if you know how to use a text editor and you can open a file in a web browser. And there's an instant feedback loop. The most important thing about computer class 30 years ago is you type your program and then you run it. And then you can make changes and then you can run it again. And I'm firmly convinced that that immediate feedback is absolutely necessary for kids that age, because we all know they have really short attention spans. But if you get that instant feedback loop, then they can start doing something and feel like they're getting somewhere and see some progress and have some satisfaction. Unlike the famous XKCD comic where they're having a sword fight because their code is compiling, which kids might enjoy too, but it's kind of beyond what you can get into at lunch hour. And the web is a simple open environment that kids already know. They use the web all the time. They've got Instagram accounts and they're searching on Google Images for stuff, and they know the web, they like the web, and the idea that they could make web pages I thought might be motivating. Even more motivating than going, go to 20, ha ha ha. There's my name all over the place. So first pass, like I was just saying, first time I tried this was very basic. It's like, okay, let's open up Notepad in the web browser. Didn't go so well. Not what I would recommend. Why did it not go so well? Because you need to understand file management to do that. And they don't teach anything about file management in schools. And frankly, a lot of adults we work with at Freeform, you have to really explain things carefully when they involve files, because it's a foreign concept to a lot of people. So they can't find the file in the web browser after they saved it because of that reason. It's like, okay, now open the web browser. Now go open that file you just saved. What file? Where is it? What do you mean? And they're not used to the idea that web browsers open files. You open a web browser and you go to Google. That's what they know. So there was a lot of barriers to entry. And what we're looking for here is zero barrier to entry to get them into the feedback loop. So I did a second pass in the cloud because the focus is web development. Part of the focus is web development, getting them to make web stuff. So it should be on the internet anyway, like really. And from the long-term point of view, what I really, you can do HTML and CSS and all of that without the internet. But I really kind of wanted to get to PHP, which is my specialty, and in my opinion, just so open and easy to pick up. It's not like basic, but it's pretty simple, and it's part of the web environment, so you can get to the feedback loop with it. And you can only do PHP if you have a PHP server answering the requests, so it kind of makes sense to do it in the cloud, on the internet. And this has gone okay. I registered a domain. The kids' school is, my kids go to Kimberly Beach's school for the southeast end of downtown. I wrote a basic intro reference sheet to HTML because you sort of think through this. You're going to have a bunch of kids sitting at a computer and they don't know what the hell they're doing. So they needed, I felt like they needed some example or something to work from, because I can't answer, I can't tell them all what to do all at the same time. And the reference sheet looks like this. So I'm not sure how easy it is to see at the back there, but there's a historical, what is HTML in this fairly simple language, and what are HTML tags? The most important thing you have to understand about HTML is the tags, and a whole example page. Just very, as simple HTML as you can get, really, and an explanation here. Now, part of my thinking on this was, okay, the kids are in grade 4, 5, and 6. They're not going to read all of that and remember all of that, but it's one page. If they got it beside them, then at least they've got real examples to refer to. And this is in the cloud. If they're really keen, like some of them would be, they can take this home, they can use their home computer with their parents, and their mom or dad should be able to figure this out, even if they're not, an IT person. It's, it's something to work on. So I think that's an important tool. And skipping ahead to some of the punchline, there are some kids who I know have taken this and used it at home with their parents. That did happen. I also did a CSS reference, but that's more complicated. When you actually sit down and try to think about how to explain using CSS to somebody, you realize how awful CSS is. It's just, well, it's not awful, but there's such a beautiful simplicity to HTML, and then CSS just messes it up. But I mean, partly that's because laying out beautiful web pages is non-trivial. Anyway, so there's the reference sheet. I made a password-protected directory on the site because I didn't want all the kids' stuff to be open to the world. For privacy reasons, didn't know what the school or the parents would think about that. I just wanted it to be like a safe place, right? And I wrote a simple file manager and editor in PHP, because what are we going to do? Have them FTP files back and forth? I mean, that's a step backwards from where we were with the first pass. The editor, edit.php, and everything, skip ahead to another punchline, everything's available on GitHub, including the reference sheet, the doc file that's the source for the reference sheet, and a PDF of the reference sheet, and the edit.php, and everything is available on GitHub. So This is what it looks like. So this is actually the example code straight out of the reference sheet. The editor does color coding now. The actual first version didn't. This was all black and white, but now it does color coding. So save your changes. You click View in a new tab. It opens up in a new tab. So there's your feedback loop. Here's your page. Macaroni and cheese tastes really good. And so there's the editor, but there's also a file list of basically every file in the folder. You just drop edit PHP in a folder, and it'll give you a list of all the editable files. You click the file, and you're in the editor. It's as close to the ready prompt as I could make the web. That's what I was going for. So what do we do at the Computer Club? What's that like? We got all these motivation and the the tools we have at our disposal. What do we actually do? Well, Friday, kids come to the library after lunch. At our school, that means they got about 40 minutes if they show up right on time. And they start coding. I've already opened up the computer to the website, trying to get as many steps out of the way so they can just sit down and they can start doing something. Once enough kids are hanging around, I'll do a lesson, I guess. There's a flip chart in the library, so like I'll write, we start with, well, you got an HTML tag and a closing HTML tag, and then you got whatever you want in the middle. Let's put a heading and a paragraph or whatever. Just really simple stuff so they can get started. And then, maybe the next week you do, okay, you want to make a link. Everybody knows about links in web pages, so yeah, they want to make links in their web pages. Well, a link looks like this, a tag, and you have this extra thing you've never seen before, a parameter in the tag, which always takes them a little while to get used to, but they figure that out. And so I'd write one example of that out, and then they just all go and try to add it to their pages or do whatever they want to do. And so at that point, I just circulate around, and they all got questions because they missed a quote, or it's not working, or whatever, or they forgot everything I said, or who knows. This is grades 4, 5, and 6, so it's ages 8, 9, and 10, roughly. Basically 8 to 11 would be the age range. Give them tips, and I found it is very helpful to suggest they talk to their peers, because all of them want to add a background to their web page, and some of them already have, and some of them haven't. So I don't want to tell all of them how to add backgrounds to the web page. It's like, go talk to your friend who did that, and then they go do some pair programming. It's actually pretty cool how that works out. And hardware. Like any self-respecting geek, I have a lot of hardware lying around. I've been doing this for a while. And so I have 11 computers in various states of working and not working at home. So I'll bring in something, a stick of RAM or a graphics card or a CPU, or I have some old 486 CPUs, the actual metal with the pins. The kids have no idea what that is. You tell them that that's what does all the computing work, and they're, the hardware always is so funny to see their reactions, because they really don't understand anything about hardware, but they have these ideas about what the computer does. And I think it's really useful to give them some practical grounding there, just to expose them to that, so they understand that it's a machine. It has parts. It's not magic. They all have a purpose. And at the end of the term, I bring in a whole computer, and we undo the screws and open up the case, and it's like, okay, so what's this part? What's that part? Because they've seen all the parts now. And so we see how they're all put together, and so on. So what did they like about this? What have I found they gravitate to or focus on or get out of it? The things that make it work. It's a real web page. It really is on the internet. They can go home and show their mom and dad and their friends, and they can, on their iPods, they can email somebody and send them a link and share the username and password at their discretion. They're doing their own thing. They're motivated because they're going to make a page about whatever they want. And I've got some example pages I'll show you, and you'll see what they're, what they're interested in and how they how they dig into it. The stimulus response loop, it's important. They make a change, they see the result, and they run into a problem, and they ask a question, and then they fix that, and then they load the page again, and the problem's fixed. And there's a process that they can go through very quickly. It's a very fast process. They all want backgrounds. When I first did this, I've got an academic idea of, okay, if you're building a web page, you need to know this and CSS and so on. But I really didn't know what to expect in terms of what would they want to do with that, or what questions would they have about making pages. Well, the first thing they want to do is get rid of the white background. And after like all of them asked this almost right away, I remembered back to the old days when, if you remember, in the mid-90s, the backgrounds weren't white. They were gray. And I think if you did any web development at that time, you probably had the same reaction the kids do. How do I get rid of that ugly gray background? And yeah, they're human beings like the rest of us. They want to make it pretty. Google Images, oh my goodness. To them, the internet is this giant bucket of stuff that's there for their use and enjoyment. And so if they see something on the internet somewhere, then to them, it's natural to just use that somewhere else. It's fantastic. It's like open source. The essence of open source and open thinking is just embedded in the way they interact with the internet. So like they know Google Images because they search Google Images all the time for other reasons. And so they immediately want to copy the image. They don't copy paste because they've been taught Microsoft Office and Microsoft Publisher. So they try to copy paste the image into the editor. It's like, nah, that's not going to work. And that's kind of one of the computer science, fifth column ideas here is the editor shows you the code. You have to write the instructions that are different from the page, and then the browser shows you the page by reading the instructions. So there's some abstraction there. And they have to not just paste the image into the editor. That obviously won't work. So you have to give them a mini lesson about finding the URL for the image that they found in Google Images. And if they have that URL, then they can put it in the SRC part of the image tag, and then it'll work. And then you can try to explain intellectual property to them, but good luck. I consider it more important to get them into the loop than worry if they're stealing somebody's image on their password-protected, test page. And YouTube embed codes. As soon as because they all know YouTube, they all love YouTube. And as soon as you show them that you can just copy this is the copy. This is copy paste. You copy that embed code into the editor, then you've got the video just like that, part of YouTube in your own page. They go crazy. One kid, one of my daughters, made a page with her video wall that had like over 100 embed codes all at once in the page. And then she tried to load it, and she called me over and said, it's not working. And like, what do you mean it's not working? What did you do? So she showed me the browser, and it's like still loading. And we're like, okay, how did you do this? The browser's not responding. Let's look at this code. So we looked at the edit page, and it's like embed codes, and there was about over 100. So yeah, I crashed the browser, and that was it. But that was the sort of, she had the most enthusiastic reaction to YouTube, but they all want to do it. So hopefully this has got your interest, and you're excited to see what they actually do. So this is a page made by one of my other daughters and a friend of hers. Well, I only have 2 daughters. Anyway, they wrote all of this. I didn't type any of this. They typed all of this in the space of about, there's one of the YouTube embeds, in the space of about, like, I don't know, 3 or 4 weeks worth of lunch hours. They put all this in, searched stuff, found the URLs. There's a copied image from some unsuspecting website. And yeah, what else? This looks a lot prettier too. I mean, my hat's off to the kids really, because this was all black and white, no color coding when they did that. So here's the page rendered. Yeah, and I didn't realize this till I was reviewing stuff for this presentation. Some body image issues for the girls there. Only have 1 chocolate bar a day or else you'll be fat. And there's videos and other stuff in here, of course. And these girls were in grade 4 when they made this. So they were some of the youngest kids doing it. So it kind of looks like the worst MySpace nightmare you've ever seen. But that's not the point. The point is they wrote it, and they had to get it all working, and it works. Now this is an older kid. This kid was in grade 6, and I would say it's almost a law of nature. It seems that boys in grade 6 will want to make pages about Minecraft. So this is a Minecraft fan page about his server, and he's got some Minecraft images in there, and there's instructions there for how you can apply to join his server. And because he was older and he was more interested in certain things, we started to try and do some PHP work here. So he made a little form, and you hit submit, and all we got to was, okay, now we're printing out what has been submitted. And if we had had more time in the term, we might have got to writing files to the disk and stuff, but who knows? So that's what they did. It's cool. Do they deserve a round of applause for all that work? Yes. So, okay, what are they learning? From an academic justification point of view, I mean, I don't know who's going to review this video later or where it might lead, but I think it's important to point out if anybody's trying to make the case for this anywhere, what are the things that they're actually getting out of it? Pattern recognition. And from a curriculum point of view, if we're going to tackle the first big X there at the ministry, we have to convince them that this is something that's relevant to the curriculum and that they will learn important things from doing this. You master a lot of pattern recognition, especially when you do it all in black and white. I added color coding for this term to the editor. But you have to recognize the P and the not P, or the closed P, go together. It's my logic background, P, not P. Anyway, yeah, P and closed P go together, and they're instructions. They're not part of what's actually being sent to the page. And you have to be able to recognize that in the code, which looks totally different than the page. And there's obviously a lot of abstraction, fundamental concept of computer programming. You give some instructions, and you get a result that is not, you know, a carbon copy of your instructions. It's being chewed through a machine, and something else happens at the other end. A lot of fearlessness they get out of this. The computer will do what you tell it to. It just establishing a positive relationship with the machine at an early age ought to create positive lifelong experiences for computers, for these kids with computers. If they are terrified of not knowing how to use Microsoft Publisher, they're going to become, you know, not computer literate people, in my opinion. They learn lather, rinse, repeat. That web pages have this fast feedback loops. You see the effect of changes. I've talked about that a lot. And in my opinion, that's the essence of all programming. You do some of that abstract patterning work, writing something, and then you inspect the result, and then you make changes, and you fix a bug, and you test the result, and so on. I think that's the essence of any kind of programming, whether it's on the web or not. So that's an important basis for if they pursue more technical work with computers later on. Third pass, so what we're doing, sort of the latest version of this. I did it 2 years ago, did not do it last year, because the teachers and the government were arguing too much, and so you need a teacher sponsor to do any of this in school. So this year we're doing it again, and we've got syntax highlighting for all 4 levels: HTML, CSS, JavaScript, and PHP. Like levels as in, you know, JavaScript executes on the client, PHP's on the server, etc. Also, each kid now has their own folder. I didn't quite get this far the first time, but I'm optimistic about how this is going to go now, that they each have files only in their own folder rather than all the files just being shared in one place. Because it should make it easier for them to make 2 or 3 files and link to them. when all the files were all in the same place, there was an issue about them identifying which file was theirs and which file was somebody else's. The school has upgraded its hardware. They used to have like about 15 or 18 computers in the library. Now they have this big case of laptops from HP. There are about 30 laptops in there, I think. And so they just wheel the case into one of the classrooms, and the kids pull the laptops out. I still have to figure out what this means for the startup cycle, because if the kids pull it out, then they got to turn it on, they got to log in and all of that. And if I can do all of that while they're eating lunch, then when they get to the room, they're sort of ready to go. That'd be better. And we have a smart board instead of a flip chart, because we're doing it in a classroom that has a smart board. So I can actually type a real page, and they can see that instead of trying to draw HTML on a flip chart. And there's no undo on a flip chart. It's hard. Yeah, so that's it. All the resources, like I said, are available. That's the page on GitHub. The editor does require the CodeMirror library now that it does syntax highlighting. CodeMirror provides all the highlighting for that in JavaScript. Another link I wanted to throw in there is this site I know of called CS Unplugged, which is computer science lessons for kids that are like you don't do them with a computer. Like they've got examples of how you do binary math with a bunch of kids holding up like 0 and 1 cards and stuff. So they're kind of out there. Like I looked at them and I thought, okay, but how much fun are they going to have doing some of these things? But I think there's some really neat resources there that, with the right teacher and the right class, could be useful too. Yeah, that's the story. Thank you. Thank you. So now you're all going to run off and show it to your kids, right? Yeah. Yeah.
Sorry, I just wanted to ask you mentioned about file management.
Yeah.
At the beginning.
Yeah.
And I've had that problem with my son in grade 5 as well.
It's a serious problem.
We've done some programming.
Yeah.
Using Scratch and other things.
Yeah.
The concepts of
Yeah.
files, he still doesn't.
Yeah.
And I can't explain it to him because I get it, but I don't know how to.
Yeah.
So how did you do it?
How did? Well, I think with the edit PHP we get around it because they don't have to know where the file is. Like the edit PHP, when they go to like kbcoders.com/their name/edit PHP, and then that gives them a list of all the HTML files that are present in that folder. And so to them, it's just a list of names, and they click on one and they get it in the editor, and then they can edit it, and like that's it.
So did you show them like saving copies or revisions or?
There is no revision because all it is there's a save button in the corner, so they type, they hit save, right. And that's it. It's like it's as close as I could get the web to the BASIC in 1983. Is like you type your program, and then if there's you want to make a change, you change the line, but you don't even have to save there because it's all in RAM. But anyway, yeah, it's like they save the file once. Well, they save the file after every change, but yeah, there's no revision history. Okay. Yeah, I was just imagining if we set up a Git repository for them and stuff. That's another story. Yeah.
This is a problem that can still be even referring to students in our semesters.
Oh no. Well, it's all on GitHub if you want to use it at Seneca.
I was thinking about like the PHP method in and of itself. How can you be sure that these kids are not simply kind of doing a monkey see, monkey do kind of thing, just regurgitating information back to you as opposed to actually being able to apply?
I suspect a lot of them are doing a monkey see, monkey do thing because they copy from the reference sheet or they copy from their friend. But to me, that's not the point because I think at Seneca, that's a problem if that's what they're doing. But the goal from my mind for kids at this age level and capability level is to introduce them to the ideas that the computer will respond to what you tell it to, and that there are ways that you can relatively easily tell it to do stuff if you're given the right environment. And to just understand some of the basic things about pattern recognition and abstraction. And if they never make another web page in their life, fine. But some of them will. And so I'm not too concerned if a bunch of them are just copy pasting and having fun and not really getting it. I'm sure they're getting something. I don't really know what it is, but I'm sure they're getting something. And it's more about preparing them for things later. Because, like I said at the beginning, from my experience, I did get more out of, the basic programming way back when, and that was actually a foundational thing for the direction my career took. So for some kids, I'm sure that's true. Not all the kids who did basic programming with me in grade 4, ever went to do anything else with IT either.
But then I'm assuming the main goal is for like computer literacy.
Yeah, it's to help them be more comfortable with stuff and give them an opportunity for those that are motivated. And I mean, that kid who did the Minecraft page, like, if you read through all the stuff that he's, I'm not sure if it was that page or another one, but he's talking about, like, the passwords should be like, the account name has to be alphanumeric and no griefing on the server, and like, this kid's in grade 6, but he understands a fair bit about a certain computing ecosystem that he's part of, and he was pretty motivated. Yeah. Yeah.
What were some of the challenges when you tried to set up this computer club from the point of view of letting the school buy into that idea?
Yeah. That's a funny story. I should add that in, actually. My main focus was to explain just the process and what we did and how it works, and pass that on so other people can learn from that. But yeah, setting it up is important too. In the particular case of our school, it was relatively simple. I talked to the principal and explained, what I had in mind, basically. And it's billed as a computer club. And they have, like, they have all kinds of clubs and activities. They have a guitar club. They have, sports stuff after school. So it's just another thing that the kids can do. And the key thing is finding a teacher sponsor who's interested in giving up a bit of their time to make it happen. Because you can't be in a school doing anything with kids without a teacher there. So it was up to the teachers to talk about it amongst themselves, and one of them to volunteer. The first year, it was actually the teacher who was my kid's teacher. My girls are twins in grade 4 at that time, and they were both in the same class, so she said she'd do it. And that was independent, not I didn't ask her, it just sort of came out of that process. Or is that true? I might have asked her. Anyway, last year there was nothing. This year the teachers talked about it again, and it was a different teacher who is not my kid's teacher at all. He was their teacher in a previous grade. So that's how it works from the school point of view, at least in our school and in the Toronto board. But the funny thing is about that I wanted to mention, I actually wrote the original version of the editor a couple years ago, like, well, more than 2 years ago when we started this, like probably about 4 years ago or something. Because I've been thinking about this for a little while, and like ever since my kids started using computers in school, I was kind of thinking about it. And we do work with nonprofits at Freeform, including at the time with the Boys and Girls Clubs. So I thought, hey, the Boys and Girls Clubs would maybe want to do that as part of, I don't know how many computers they've got, but if they've got something, they do after school things or whatever. And I emailed some people I knew there, like inside the organization. This wasn't just somebody contacting them at random. So I thought I might get somewhere. Got nowhere. And there was another organization that I forget who it was, but same kind of thing. And so that was kind of surprising and disappointing to me, because I guess these organizations have their own programs and their own things that they're focused on doing, and this is just sort of one other thing. Whereas in the school, they do have clubs and other things, and there's maybe more of a there's more of a pattern that you can fit into and pull off something like this. Yeah. Yeah.
Well, you're bringing in the hardware. I think that's a brilliant.
Oh, thank you. Yeah. Yeah. The tool maker with the thumbs, right? That's, yeah.
One other question. How many students do you have?
Yeah, the numbers. At the beginning of each term, there's always the most, because they hear about it and some of them, they like computers and they think it's fun. When we started this year, we actually had probably about 35 or 40 kids in the classroom, and there's only like 28 or 30 computers. But I know from doing it before, like there was a drop off about 50% to like the second week, the third week. We haven't actually done the second session yet for this term, so we'll see how it plays out. But yeah, when we did it before, we started with maybe like over 20, and then on a regular basis, it got down to around between 8 and 15 would show up any given day. Because the kids that age, a lot depends on like what else is going on at lunch hour too. Because one week it might be, oh, there's this special meeting of whatever, or it's spring and it's really nice weather outside, so they just want to go play tag or whatever, or soccer, baseball, whatever soccer, baseball is. That's what my kids play now. So you've got a lot of competing interests at their disposal. So we just, every week I'm there, and those who come, and it does vary between, under 10 to, around 15-ish usually. Yeah, it kind of depends on the size of the school. At our school, there's a total of around, I think, not more than about 200 to 250 students. So we're getting like, 10% or less of the students actually engaged on a regular basis. Yeah. Yeah.
Teacher who's there, whatever the word is, could be an educational vehicle, he would pick up, or he would pick up on sponsor within the school or something.
I'm optimistic that that might happen this year, because I think the teacher who's involved now is, the one that I worked with before is great, but it's clear that she wanted to help make it happen, but she wasn't going to be learning how to do it. Like I think she felt the computer stuff was just, she got other things she's focused on. But I think the teacher who's doing it this term may be more interested in learning how to run a class himself. And certainly I've tried to gear all the resources and the reference sheet and so on like to a level that he could. Anybody who's got a rational bent ought to be able to, because all the information is in there. This is what this tag does, this is what this parameter does. Like, if you can decode that, you can figure it out. Oh, like run it for the teachers or something. Yeah. That's a really interesting idea. I would love to do that. I'll have to talk to them about that a bit more. Yeah. Yeah, because ultimately it's geared to make it all accessible. And we're talking about kids because they need it to be really accessible, and we want to educate them and give them a grounding. But the idea that it's really accessible applies to any group that needs it to be really accessible. Yeah. Yeah. Yeah, no, they're a resource for the school. They live in the staff room, and anytime they do a computer activity in class, the teacher wheels them down to the classroom. There's a wireless hub on it. It's a nice setup. It's an impressive setup. But they still have to remember their school password and log in and all that. Like, seriously, why do they have to log into a school laptop? Really? Like, what is the real rationale for that? Really? Yeah, maybe. I don't know. It's weird.
It's later on that ties into their Moodle password.
Well,
Same username and password
yeah.
they're gonna have.
No, that's true. It is an institution-wide password. Yeah. Yeah. Yeah, fundamental. Yeah, absolutely. Yeah, no, that's a really fascinating environment too. I'm a web developer, so I was wedded to the web, but yeah, there's other things like that out there that can do similar things.
They deliberately try and infer if we learn syntax and focus more on
Yeah, the actual relational concepts of how the pieces fit together and stuff.
It seems like it's very similar, but in another direction, focusing on like easy syntax.
Yeah, yeah. HTML is so darn forgiving. Like you can leave out the ending tag, and your page might still mostly work and stuff. So I think HTML is a beautiful beginning point for kids from that point of view. The syntax issue. They all have trouble with like, oh, they forgot the close quote on their image source, and now the whole rest of the page has disappeared and stuff. But that's real debugging. That's like a real problem that happens to me once in a while, like all of us who do any of that kind of thing. So why shouldn't they? And it's simple to solve. And now with the syntax highlighting, everything else on the page is going to be red. So it'll be really easy for them to spot that kind of stuff. So I think it's a I can appreciate the desire to leave the syntax out of it and get them to focus on the concepts. But I believe that the most important thing is driving their motivation, driving them to want to do something and being comfortable in the environment. And I also have a strong bias towards real world stuff. Like these are transferable skills. Scratch is transferable, but only from that abstraction point of view, that if you've internalized all that stuff they're trying to teach you, then you can apply those principles elsewhere. Although that kind of gets to what you were saying about how much are they actually getting out of this even. It's not a simple question. Yeah?
I just be curious, you talked about you created that activity, right? You know, I'm just curious, are they working in a shell environment?
No, they're working in a PHP editor that I wrote. Oh, I hit the wrong thing. I can go back to that. Oh, what the heck was that? Okay, I'll call up the editor video when it loads. Oh yeah, it's hit the GitHub link somehow. Yeah, make this full screen. There we go. And allow that. So yeah, one of the things to talk about at the beginning is that shell environments and IDEs and all this stuff is like one of the reasons that this is not happening in grade school, and we need to get to a much simpler environment. So the editor is right around here. Yeah. So this is a little demo of how the editor works. This is a PHP script. They type in the file or whatever commands they want. They hit the save button up there, and then you can view the file in a new tab, like render it, compile it. That's it. Yeah, but it's like it's a simple little script. Actually, as far as we're talking about technology, though, I found that the domain that we're running it on is really simple, low cost, and they have lots of security things in the way of PHP working. They'll actually strip PHP out of form submissions. So I actually reverse the entire contents of the editor when we submit it, and then flip it back when we receive it on the server, and that bypasses all their filtering quite nicely. Yeah, it's funny with the odd things you run into. But anyway, it's one file. So all you do is you drop that one file in the folder, and you're good to go. Yeah.
Well, thank you very much, Julian. On behalf of Seneca, we just want to give you a small token of appreciation.
Thank you.
Thank you very much. A reminder that there is refreshments available in the collaborative room. You can just, as soon as you come out of the